Roger Wang, Lead Strategy and Product Manager for Data Analytics and AI in Interac, which is a company that certainly have invested a lot on AI. And he's going to talk about MLOps, building trust in machine learning at scale. So welcome, Roger. Here you are.
All right, everyone can hear me? Okay, so hi everyone, good afternoon. My name's Roger Wang, Data and AI Strategy Lead at Interac. First of all, thank you all for deciding to stay at the end of a two-day conference for a 4:30 session on MLOps. Obviously, more exciting than generative AI or AI agents, so good for you guys for pulling through. So over the next 30 minutes or so, I'll talk you through how Interac is scaling AI and machine learning through MLOps, not just to deploy better models, but ultimately to build more trust and resilience in the Canadian financial ecosystem. So a little bit about Interac first. I'm hoping everyone's already fairly familiar with the organization. Interac is one of the oldest fintechs in Canada. We offer various products and services across payments, money movement, digital wallets, and identity verification. We're probably most well known for our debit network, as well as e-transfer for peer-to-peer and B2B payments. We also have Interac Verified, which is for identity verification, as well as building out the next generation of the Canadian digital wallet solution by Canadians for Canadians. And lastly, I think those of you in financial services might be aware of this. We're also building out real-time rails, which is going to be the next evolution of Canada's payment infrastructure, enabling instant and data-rich payments. So we like to think of ourselves as the connective tissue across the financial ecosystem, connecting banks with acquirers, merchants, the government, as well as consumers. And in order to achieve that trust and retain that trust, we really need to build out essentially a infrastructure of trust, right? So that gets down to our sixth core product, which is fraud services, to ensure that every single transaction that happens across any of our products are protected from malicious actors on the network. So while Interac is doing things across various domains within AI, including predictive machine learning, agentic AI, generative AI, I do want to orient a lot of today's conversation around fraud specifically, because I think it's one of our most mature machine learning solutions, and it's also a really great illustration of the journey that we went on in terms of MLOps. So a little bit first about sort of the contextual drivers and the operational realities that kind of inform our approach to MLOps. Firstly, and unsurprisingly, we're highly regulated. Two of our products, both e-transfer and debit, are designated prominent payment systems. So that means that these products and any sort of machine learning solutions attached to these products must meet the highest standards in terms of things like auditability, in terms of things like explainability, legal defensibility, these sorts of things. Secondly, trust is at the core of everything that we do. So our products and services are only as good as the trust that the ecosystem places on them. So I think the saying goes, with great trust comes great responsibility, or something like that. You get the general idea. But that means that we cannot afford any level of failure in our systems. Thirdly, we have massive volumes of data. We're dealing with millions of transactions every single day, and that's very demanding on our infrastructure and our platforms, which need to be sort of scalable and adaptive in order to keep up with that growing volume of data. And then lastly, we're dealing with very, very fluid behavioral patterns in our data, especially in the realm of fraud. So when I first joined Interac, I was a little disappointed to learn that fraudsters, when you catch up on their methods, they don't just give up and lead a more ethical life. They're actually very adaptable, and they'll change and they'll figure out new ways to exploit the system, right? So in order to keep up and stay ahead, our systems and our models need to be just as adaptive, right? So all of that informs our objective at the end of the day, which is to deliver resilient, adaptive, and responsible AI models and systems that enhance the performance, security, and trustworthiness of Interac's digital services. So at the end of the day, it's not just about deploying and optimizing models. It's about creating a sustainable, scalable, strategic capability in order to support the future of AI and machine learning at Interac. So a little bit about our approach and our journey. I think when we first started on this MLOps journey, we, like many organizations out there, we started with isolated models, promising use cases, and some very, very smart data scientists. But we realized quickly that in order to make AI sustainable, it was not just about building the best models out there, right? It was about building a more reliable system. And over time, we were able to develop that more structured, strategic approach. And we treated our AI and machine learning models and solutions as products in and of themselves. And MLOps essentially just became the operating model through which we ideated, we built, we deployed, and we operated our products, right? So everything, as you can see, starts with a strategy and data product ownership. Then underneath that are our core capabilities, which span the entire life cycle of machine learning, from data and feature management to development to deployment, all the way through to observability. And there's capabilities under each of these pillars, which I won't go into detail. I think every single one of these could really be a talk in and of itself. But underpinning all of that is, of course, governance and compliance to make sure that everything that we do is ethical, is transparent, and is compliant, right? So as you can see, there's a lot of capabilities on one page, and I think most of you, like us, can't mature every single capability, right? You have limited resources, you have limited people, you have limited time. So the logical next question is, how do you determine which capability to focus on in terms of maturing, right? So that's where we had to take ourselves back to the basics of operations 101, right? So bear with me and just forget the machine learning part of MLOps for a second and just focus on the operations. Whenever you want to make a process more efficient or effective, in operations, what do you do first, right? You look for the bottleneck. You map out your process, you figure out where your product is getting held up, where that quality of that product is degrading, and then you focus on that bottleneck, and you create or you identify the root cause, you create a hypothesis, you find a solution, you implement it, you ensure that you have ways to measure whether it's actually improved the effectiveness and efficiency of your process. And once that's been validated, that's when you move on to the next bottleneck, right? So bringing machine learning back into the equation, it's fundamentally no different. If you think about your product as the machine learning models themselves, then the manufacturing process is essentially that end-to-end machine learning lifecycle and workflow. And all you're doing is looking for the friction within that end-to-end process and trying to solve those bottlenecks one at a time. So nothing overly complex here, but maybe a little conceptual. So I want to take you folks along our journey of how we've applied some of this thought into trying to solve our own bottlenecks, right? So starting with data and feature management, the issue that we were coming across, and I don't think it's a bottleneck that's very different from many other teams out there, is that we had long lead times to identify and get access to the right data, training data, and understanding the details, right? So those of you who are data scientists or work with data scientists probably know that they spend way more time digging for the right data, trying to understand what that data actually means, than to actually build the models themselves, right? So the root cause that we determined once we investigated a little further was that we had poor data lineage, we didn't have proper documentation for a lot of our core data sources, and we didn't have proper accountability for those data domains, right? So the solution that we came to then was back to the basics of governance, of making sure that we built out a comprehensive data management system data management program, ensuring that we had reusable assets like data catalogs, data dictionaries, automated data lineage to make sure that our data scientists, when they needed data and when they wanted to understand that data, that it was easily accessible and they weren't spending more time hunting for the data than to actually use the data. And along with that, we needed to build out a more comprehensive stewardship model so that there was proper accountability for those data domains so that when issues arise with data quality or data accessibility, that there was proper accountability in terms of who has the authority to go and fix that. Again, just taking some of the workload off of our data scientists and ensuring that they had the assets they needed to do what they do best, which is developing and operating models. Next, from a model development standpoint, the bottleneck that we were facing was inconsistent model performance and lack of reproducibility. Right? So it was often difficult for data scientists to collaborate with each other and stay organized with their data and model experimentation. The root cause here was really there was lack of standardized workflows for developing and experimenting, and the experimentation was sort of ad hoc. So this model worked okay when we had some simple models and a few data scientists each working on their own model, because they could kind of follow their own method and they don't have to care too much what other data scientists are doing. But where this became a bottleneck, right, was when our models became more complex and there required more collaborative effort and proper testing and vetting for these models. So when that became a bottleneck, we did the root cause analysis, and the solution we came to was putting together a more collaborative development framework that included shared development environments, experiment tracking, model registry, data versioning, all of these great things so that the data scientists didn't have to worry about manually tracking their experiments, not being able to reproduce the results of a previous model, and again, unblocking them so that they can do what they do best. Next, from a deployment standpoint, I think this to me was where it was most interesting, I think a bit more unique to fraud detection in general. The issue that we were coming across was that model performance and complexity were both somewhat capped by the limited compute and on the operational databases. So if you think about fraud detection models, the freshness of features in those models are really critical. So if you think about some of the features that we might productionize for a fraud model, I don't want to give you folks a secret sauce, but you can think of every transaction that comes in as potentially informing whether the next transaction is fraudulent or not, right? If you have the same account sending transactions back to back, then there could be some information in those prior transactions that help us determine whether the next transaction is fraudulent or not. But as we wanted to go more complex with these features that required more compute, we realized, first of all, we lacked the infrastructure scalability. So when we originally built some of this infrastructure, a lot of it was on servers, and that limited the scalability of the compute resources, and then that ultimately limited the complexity of the features in our models. And secondly, we also didn't have a real-time feature platform, so we couldn't sort of manage features in a more organized manner and serve them to different models in real time. So the solution for us, and some of this work is still happening, is to, number one, migrate our inference infrastructure into the cloud in order to remove some of those hurdles in terms of scalability. And secondly, to actually implement a real-time feature management and feature serving platform to ensure that we had the flexibility to operationalize more complex features across multiple different models and have that not be all on the operational database in terms of a compute load. So this is going to be a huge sort of unblocker, call it, for our data scientists when they want to look for those more complex and more useful features for our models. And then lastly, from an observability standpoint, I think this is also probably a common problem that folks face, which is blind spots after deployment of models, right? It's difficult to surface issues and identify root causes. I think it's a very easy trap to fall into for data scientists to build an amazing model, amazing metrics, and then operationalize that, and then move on to the next model. And then when they have some capacity, 6 months from now, they come back to the model and they're like, oh no, it's the performance has degraded, and it's not as useful as it used to be, right? So for us, a root cause, I think it's the same for many folks out there, which is manual drift detection, whether it's data drift, whether it's model drift, as well as misaligned business rules. So when we were trying to set up any alerts that we could, they weren't necessarily alerting against the right things, which were the priorities of the business. So for us, the solution was to really implement a real-time observability tool that included things like custom drift detection and alerting, while working with the business to define what those detection rules are so that the alerts that were coming in were actually indicative of what the business defined as model degradation, right? And then cannot forget AI governance, which underpins all of those capabilities, right? So the objective for us of AI governance is to operationalize models that are ethical, compliant, transparent, secure, and accountable. And there's 4 key components to AI governance for us. So first is risk and compliance management, which is making sure that you understand the regulatory landscape and being proactive in setting standards and policies. So proactive is probably the key word there. If you're just sitting around waiting for the government to pass ADA, you're going to fall behind. So you need to understand sort of what's the regulatory landscape, more broadly speaking, what's the EU doing? How do some of those policies apply against your specific business objectives and your unique circumstances, and design proactive policies that you can hold yourselves accountable for, so that when these actual legislative rules get passed, that you're not falling behind there. Secondly, operational control, so putting the right processes and gating in place to enforce your policies, whether that be model governance, whether that be monitoring and incident response. Thirdly, you can't forget culture and training. And culture and training is more than just your data scientists. It's about the broader organization and taking them along for the journey, so that when you need to have conversations about compliance with compliance teams, privacy teams, legal teams, risk teams, information security teams, that you're all on the same page about how these models and these systems fundamentally work, and ultimately not sort of just talking through each other because you don't have the common understanding of these systems. And then most critically is ownership and accountability. So your policies and your procedures are ultimately only good as the people's ability to follow and enforce them. So for us, it meant rolling up some of our AI solutions, our machine learning models, into our data governance council to ensure that there was executive oversight and accountability, and also expanding our data stewardship program to also encompass some of these models and these systems to, again, ensure that there was ownership when issues arose, whether it be audits or just questions around how these systems work. And then lastly, I'll take you through sort of some of the challenges and learnings along the way for us. First, and I think this is so obvious that I shouldn't even have to put it on the slide, but I think it's a common theme for everyone here, is start with the strategy and the requirements. And I would be lying to you all if I claimed that I never chased after some shiny object because Google or McKinsey released some amazing architecture document or some sort of tool that's supposed to solve all of your problems when it comes to implementing AI and machine learning. But ultimately, for 90% of those fancy architectures, fancy tools, you either don't need them or you're not ready for them. So it's about understanding what are your core strategy priorities, how do they roll down into requirements, and what capabilities actually fulfill those requirements, right? The second is clarifying the difference between data readiness versus data quality. So data quality, everyone needs to focus on. not even a debate, right? But data quality will never be fully achieved. Data quality is an ever-changing target, and data readiness is what truly unblocks your data science teams, right? So it's critical that you work closely with your data science, your data engineering teams to actually understand what data they need, whether it's data domains, data sets, critical data elements, so that you can focus on solving the quality of those assets and unblock them before focusing on the broader data quality, because data readiness is much more achievable and is constrained to your specific use case. Thirdly, it's about differentiating between model performance and business impact. So I think a lot of the times we can get lost in the amazingness of the new model that you've recently operationalized and forget that there's downstream business consumers of these models. And it's important to understand and question things like, what's their risk tolerance? Do they care more about minimizing false negatives or false positives? And understanding those unique needs and tying them back to your own performance metrics for your models to actually make sure that there is business impact that's driven out of this. And then next, I've already talked at length about finding the bottleneck, but just want to repeat myself. Again, taking that operational mindset and practicing radical prioritization in terms of what capabilities you actually need. And then fifth is empowering your operations teams. So again, going back to the theme of understanding the end consumers of your model outputs, it's truly important to understand what's the operational impact of your model. So for us, if I were to take fraud models as an example, the immediate end consumer of that are our fraud operations teams that reviews these alerts and have a limited amount of time to conduct their analysis and make a determination of, hey, does this look like a false positive or a true positive? And when we work closely with them to understand their needs, it was apparent that just having the model scoring wasn't sufficient, that we could be providing better assets, like things like explainability, in order to guide them in the right direction of what information could help them and enrich their analysis in order to help them make a better determination around these fraud alerts. And then last but not least is around change management, right? So change management is critical. I think a lot of us make the mistake of thinking that change management is something that happens at the end of your project, but ultimately it's from start to end, right? So I think we've made some, we've had some learnings as well when it came to change management, because we would build these amazing models that we felt like were no-brainers in terms of the stakeholders adopting, and then we realized quickly that, hey, there's so much more both upstream and downstream in terms of actually operationalizing these models. Downstream consumers need to understand what are the implications on their operational processes. How do they need to change their staffing to accommodate for the alerting of these machine learning models? All of these things are critical to consider and are critical to take your stakeholders along for that journey so that you don't get into a circumstance where you're putting in more effort operationalizing the model than actually building the model. So with that said, again, if there's just one takeaway from this presentation, it's to understand that MLOps is not just a technical discipline, right? Yes, you need to care about the pipelines. Yes, you need to care about the platforms. Automation, of course you need automation, but ultimately it's truly a strategic capability, and it's how we at Interac have been able to scale trust, how we make AI real, and how we've been able to prevent over $60 million of fraudulent transactions just in the last 12 months, collaborating with our financial ecosystem. So with that, happy to take any questions. Yes.
Thank you for the great presentation. And I wonder, like, when you have worked with siloed data in your company, because that is a common problem with all the enterprises, right? So is there a time when you have a challenge when trying to find the data for your data scientists to start your use cases? What did you do, and what's your key points in overcoming this challenge?
So I think for us, the two main call it solutions for that were, first of all, sort of the accountability model, and secondly, like the infrastructure, right? So I'll start with the accountability model. It goes back to sort of the data management program, ensuring that there's data stores, that we onboard data domains, and that those data stores actually understand what data is a part of their domain, so that when a data scientist say, oh, I need marketing data or I need operations data, they know who to go to, and that person can help direct them in the right direction. And secondly, from an infrastructure standpoint, it's about building out more extensible infrastructure that can connect to each of your different systems, so that you can not necessarily centralize, but have the flexibility to reach out to these systems and grab the data that you need once you've identified the right paths with your data stores. I think. Oh, hi.
I would like maybe to really try to explain more on the concept of data readiness and data quality. At what point do you say data is ready? And then what is the level of quality that you need in that ready data to proceed without having high quality data?
Sorry, can you repeat the second half of your question?
At what point do you proceed with a data that is ready? What is the level of quality that you even need in that ready data?
So that's a great question. I think data readiness, there's no sort of perfect checklist in terms of when a data is supposed to be ready. I think it's very use case dependent, and that's where it's critical that you're working with your data scientists, your product owner, and your engineers, right? Because depending on the intricacies of the model that they're trying to build, there's just some data elements that you don't need to be in perfect quality, right? Because they're unlikely to go into the feature set of that model. So it's about working with them on, and that's where the data catalog is critical. So here's the entire data catalog, here's the data dictionary, identify here's sort of the key data elements, set the standard with them in terms of what it means for it to be ready for their specific use case, and that then becomes your checklist in terms of what quality is good enough. Anyone?
Hi.
Oh, sorry, where? Oh, hi.
You spoke about the RTP rails at the beginning, right? So in terms of payment processing, you need a definitive answers, especially in the RTP rails, which is now coming up with the high-speed processing, 5 seconds and so on. Mm-hmm. Do you see any role AI would be playing into it, which is more predictability instead of definity?
That's a great question. I think it ties back to a lot of our conversations around fraud. Part of the driver for us to implement some of these additional capabilities like feature store, feature serving platform, real-time observability is because of the criticality of getting real-time data for real-time rails, right? So we're still working out the details there. We're still in the process of building RTR, but a lot of these capabilities will go a long way in terms of automated decisioning around fraudulent transactions and things like that. And I think that sort of gets at your point around using AI in terms of real-time payments, because a lot of it will be sort of split-second decisions around sort of the validity and the legitimacy of these transactions, right? I think there was...
Thank you.
Oh, yeah?
Yeah, hi. Thank you for the very nice talk. I wondered if you had a strategy for platform selection to support MLOps practices.
Yeah, I love that question, and it's something we debated at length internally. I think when it comes to the strategy, I think a lot of it is stakeholder management. So as a financial services firm, a lot of it is figuring out what the constraints are from legal, from privacy, from information security, because a lot of that sort of dictates the realities of what platform we can actually use. And on top of that, you need sort of a buy versus build decision criteria in order to determine, outside of like the constraints that we've already identified, what level of criticality does the system have? Do we have the resources internally to build this up? Are there the proper components at these hyperscalers like AWS or Azure to actually build it ourselves? And how much effort would it be to maintain? And compare that with sort of the additional cost of SaaS licensing. What platforms exist that's already been operationalized? And then you also have to think about vendor risk. So like vendor lock-in. How big is a vendor? Are they at risk of sort of going bankrupt? All of these factors you need to kind of build into some sort of a criteria. And that's ultimately what drives our decisioning around sort of tooling and capabilities on our unified platform. So thank you, everyone.
Excellent. Roger, thank you very much. That was a great session, really.